my name is Elizabeth Sweeney. My role at Chevron, the title kind of is a mass balance advisor, but what that really means is, in terms of Agile, I'm kind of the product owner for Sigmafine. So my first exposure with Sigmafine was back in 2001, so that was version 3, so I've kind of been in and out of this space for a long time. And so kind of give you an overview of what we're going to talk about. So Chevron is on a digital transformation journey, just like many companies are these days. And it'd be a rare speech for our CEO to make if he didn't mention digital transformation. So we were definitely on that bandwagon. And part of that is improving the quality of our refinery process data and automating as much of that data flow as possible, particularly around existing production accounting and data reconciliation processes. So in this presentation, I'm going to discuss how we're planning to replace our aging and disparate systems that we're currently using to manage the inventory, material transfers in the refinery, and external purchases and sales of feedstocks and finished products. So we are in this project about what we say, if it's waterfall, we're like in phase 3 now, where we've already made a selection. So we have chosen a suite of applications from PIMSoft, and the objective of that is to reduce our overall cost of ownership, because we're replacing many, many different pieces of different systems and applications in this project, and to build a sustainable solution for the future. I'm going to tell you a little bit about Chevron Pascagoula Refinery. That's where I'm based. And whatever we do, we're kind of doing our proof of concept there in Pascagoula. So I'm going to tell you a little bit about Pascagoula first. But what we do there will be migrated to the other facilities as well. So we kind of want everybody to have kind of the same infrastructure and applications. I'm going to go a little bit into Chevron's experience and journey with Sigmafine, what we're planning to do next, and then the business objectives of the new models that we're building. Okay. So Chevron Pascagoula Refinery originated as Standard Oil of Kentucky. We had our groundbreaking in 1961. We're located in South Mississippi, right on the coast, very close to the Alabama state line, and east of the city of Pascagoula. We're situated on Bayou Casat, and we have more than 3,000 acres of property there. We employ approximately 1,600 employees, 2,500 contractors. And we have grown to be Chevron's largest U.S. refinery and one of the top petroleum refineries in the United States. Pascagoula is a complex coking refinery. We also have integrated chemicals with Chevron Phillips and base oils plants there at the refinery. Most of our crude supply arrives by marine tanker, but we also have 2 pipelines that supply crude as well. And 65% of our refinery products leave the refinery via ship or barge, but we do also handle other modes of transportation: pipeline, rail car, and truck. Okay. So a little bit about our journey. So prior to 2010, we kind of had various independent projects going on throughout the system. The one that I was initially involved with in Pascagoula was what we called Rambo Project. Any guesses to what that stood for? It was Refinery Accounting Mass Balance Optimization. So it was a pretty creative acronym there, I thought. Not me, it was another IT guy that came up with that. But that was our initial deployment of Sigmafine, and that was version 3 when it was under OSI. We also, at the same time, got our PI systems installed at all the refineries during that project, and we also got Process Book as well. And let's see, that was all. At the time, we had, no, that's the second project. We had 7 refineries. But anyway, our focus back then was to replace our legacy inventory and yield accounting systems. Then in El Segundo, prior to 2010, after that initial deployment, version 3 wasn't really good for production accounting, so they kind of put it on the shelf and kind of put in a collection of spreadsheets and other things. And And then El Segundo Refinery in California, kind of picked Sigmafine up as a project that they were doing, kind of to replace their process monitoring system that they had. So they came up with a process monitoring and information system that we called PROMIS for short. And that was basically a front end to Sigmafine. So it was all in-house Chevron developed software. Operators used it to log all their transfers. And it also did, or does, meter flow compensation, things like that. And it would pull all of our transfer data in and get it ready for Sigmafine to use. And then we also at the time before 2010, we had our refinery in Pembroke who was using Aspen Advisor to do mass balance. Then in 2011, we had a big global manufacturing mass balance project, and that kind of expanded the use of Sigmafine to all of our equity refineries. This is when we had it at 7 refineries. So there were 3 major refineries, 4 niche refineries that we did this with. And so we put PROMIS in everywhere and Sigmafine in everywhere. So when they did the alternatives analysis, it was basically between, do we use the PIMSoft Sigmafine software, or do we use the Aspen stuff that Pembroke has? And the team selected PIMSoft just because we had Pi systems everywhere. They felt like Sigmafine was much better at integrating with Pi. And so that was primarily the reason that was chosen. So today, we're still using Sigmafine from that global mass balance project at all the equity refineries. And we recently just upgraded. So we've been on 4.5 since 2010 or 2011. And we just recently this year upgraded to 4.7. Okay. So the way we're using it today, it's really just run by our mass balance engineers. So we have one engineer at each location, and their responsibility is to run daily cases. So what's included in that is it's feed and product meters to process units. We do have tank inventory and transfers that are within that boundary. We include transfers for marine, pipeline, truck and rail, and all of that. But we excluded fuel gas, sulfur, hydrogen plants. We don't do anything with utilities. We do run daily cases midnight to midnight. We're really just running the mass balance analysis rules. So right now we're not doing any composition tracking with Sigmafine. We did experiment with that a little bit, but it was nothing that we really put into production. Basically what we track is the DX1. So we kind of have a target for the mass balance engineers where we say they have to close each case to a DX1 of less than 5% every day, or they've got to keep trying to figure out why they can't close the case, what's wrong with the data. So that's kind of been the primary metric that we've been monitoring, although we've been talking about, what does a good case look like? And usually that could be more than just the DX1, because you could have a good DX1 and still have some real serious data quality issues. So we've been focusing a little bit more on do your tanks balance, as well as your DX1 being in a good spot. So this is kind of our current infrastructure. It's not exactly this way at all the refineries, but this is generally how El Segundo at least is set up. So we had the PROMIS system, which would pull in the raw volume for meters and calculate the compensated volume, put that back out to Pi. And then Sigmafine would just pull in mass. So we weren't pulling anything other than mass into Sigmafine, or at least not at this point, not pulling anything other than mass. And then it would run the data reconciliation and then write to Pi tags that were just reconciled mass. And then it had to go back into the PROMIS system because that's where we were maintaining all of our meter data. So it had to go back out to PROMIS to convert mass back to volume. And then it was available for reporting dashboards. So PROMIS had kind of the front end tank and inventory, our inventory and meter calculations it would do, and the Sigmafine was just for data reconciliation. And then PROMIS would convert it back to volume and then make it available for reporting. So it was a little bit, kind of PROMIS was the center of the world really in the way that it was designed. Okay, so next steps. Back in 2011 when we did this project, our business cases, we were after what everybody's after when they put this stuff in, is they want to increase the refinery profitability. And so there were all these things that were, benefits that we expected to get out of the project. Things like planning and operations can make better business decisions, higher visibility of the data, accurate reporting, more timely feedback, high quality data, performance data, all of these things we were expecting to get out of the project. And that project was back in 2011, it's 2019, or we're looking at, this was actually started a few years ago, we started looking at it going, why aren't we seeing all of this benefit that we expected to see out of putting in this process in this application? So we had some successes. I don't want to say there's not, but there were some, and it just wasn't as robust or what was expected. So I kind of started doing health checks, is what we called it, sort of like an audit, where I started visiting all of the refineries and interviewing everybody and trying to figure out, how do you use the data? And so kind of what we realized is when we put this in, it was a standalone work process. It wasn't linked to any kind of business critical work process. It was just kind of over here to the side, and we generated all this data, and that's nice, but how am I going to use that data? And then the way that we had developed the mass balance engineer role, it was kind of a development role. It was like somebody comes in for 18 to 24 months, and then they're gone. So really building up that organizational capability around Sigmafine, the Sigmafine tool, it was really hard to get somebody up to that caliber where they could really be an expert in the software. And then another biggie, which is kind of the reason that we are doing this oil movements program, is there was just such a diversity in the supporting software applications that fed Sigmafine or fed Promise. Everybody was using something different. Even though we kind of put Promise in to do meter flow compensations, only 2 refineries were using it, and everybody else was doing something different. Tank net volumes were calculated in different systems and in different ways. And then collecting that oil movement data, like just the collection of the transfers. They were all using different applications for that as well. So that kind of limited our ability to standardize and automate things. And then even though we were sticking all this data out there, we're only sticking out meter data for the most part. So we stuck out reconciled mass, reconciled volume for meters, and that was really it. If you needed any other information, it was really kind of hard to get at unless you were the mass balance engineer and you knew where to go to get it. So these were kind of major things that kind of came out of those health checks. So that kind of fed into this oil movements program, and they actually titled it Oil Movements and Production Accounting Program because the production accounting piece was such a big part of it. So it's a program and not a project because it's really multiple projects within it. So there were 6 work streams that were identified. The objective was to replace all of these obsolete marine scheduling, oil movements, mass balance and production accounting IT systems, and then provide an integrated set of systems that would meet all of our functional requirements and reduce the cost of ownership by using sustainable vendor solutions. So we're really trying to limit in-house developed software and go with something that's a little more standard. And that kind of reduce our IT support costs too, because then we can call Joey on the support line instead of having to find somebody in our IT department who doesn't know a whole lot about Sigmafine anyway. So the diagram here is just kind of like at each refinery, those are the work streams and the applications they're currently using. So for marine scheduling, Seabirth operations will be using MES from Cirrus Logistics. We're going with the Honeywell PIM and PMM for the oil movement software, and then for production accounting reconciliation, we'll be using the IMM and Sigmafine on top of that. Okay, so for the new Sigmafine models, we will be rebuilding our models because they were designed more around what process engineering wanted and not really what we needed to build a refinery stock balance. So we will have to add some tanks and things to make it usable for production accounting. We'll be replacing our process monitoring information system with the PIMSoft IMM and Intelligent Movement Management software, and we'll be using an integration framework to integrate with the other systems. So our goal is to optimize the stock accounting process, which means minimize manually entered data as much as possible, reduce time in the identification of missing movements, and extend Sigmafine calculations to tank inventory and movements. So, right now we haven't used any of that functionality in Sigmafine. It was really just a mass balance. So we're putting in our tank strapping tables and and so that IMM can recalculate the net volume for the transfers that come in. So there's a lot of work that we'll need to do to configure all of that. So this is kind of a diagram of our current configuration and kind of it's really our interim configuration, because we're going to go ahead and do this ahead of the Honeywell application. So in the meantime, we're using an IP21 system in tank field, and we'll have to use that until the Honeywell stuff comes online. So we'll have integration framework for that. So on the left, the IB21 system goes into a yield accounting system called paperless pumpers log that we're using in Pascagoula only. And then that feeds Promise currently and goes into Sigmafine, and then we stick the meter data back out to Pi. In our interim, and then SAP is fed by this yield accounting system, the PPL. And then our future configuration, we'll be pulling everything in through the integration framework and processing the transfers through IMM, then sending that to Sigmafine. We'll do our reporting through SQL Access. Actually, we're going to use Microsoft Reporting Services, but we will have the SQL Access. That will go into the Sigmafine database, and then from there we'll do the integration to SAP directly from Sigmafine. So, so direct users of Sigmafine, right now we just have mass balance engineers who run the cases. In the future, we'll have our production accountants running Sigmafine. Their responsibilities, and this is kind of what we think is going to happen, so we're hoping this all works out. So the production accountant will be primarily responsible for making sure that the proper sales and purchase volumes are recorded so that we can facilitate the proper invoicing and payment. Validate the refinery inventory, so finance is real concerned with are we accurately reporting the inventory on our books. So, so they'll probably be primarily responsible for chasing down the inventory stuff. They'll do daily composition tracking for crude tanks. That is currently done in the PPL system that they're using in finance, so we'll move that into Sigmafine as well. And they will run like the initial mass balance case in Sigmafine, and then generate the refinery stock balances. One of the things that we want to get out of this project is daily production and consumption numbers. Currently, those are really only officially reported once a month for SAP. We are kind of doing weekly stock balances and then sending inventory to SAP, but for like official numbers, that's really the only frequency that we're doing. So we're going to go to kind of a daily stock balance approach for that with Sigmafine. The mass balance engineer is still going to have a role to play. They may not be running the daily cases, but they will be ensuring that there's good quality data. So I liked the term I think that Bernard used was data engineer. They're probably not going to be mass balance engineers anymore. I'm thinking more of like a data engineer where they're responsible for ensuring we have good quality reconciled data. So they'll be looking at the cases every day, working with finance on, do we miss a routing or do we need to add something, whatever they need to do to help troubleshoot cases. They would be responsible for keeping the model and supporting tools updated with the best available field data, so the engineer is responsible for if there's a change in the field, we update it in the model. And communicate any data issues to relevant stakeholders, so they would be the people working with process engineering directly. And then also working with operations planning, PE, to improve the unit yields, and then coordinate meter flow compensation and meter maintenance process. So they are a key player in the meter maintenance program, is what we're kind of the way we're redesigning things. So the data consumers, so the reporting is a big deal for finance. There's an awful lot of reports that they use. So this is kind of just a sample stock balance report that we'll be using. But the data consumers, it's basically, all the people that care about data in the refinery. So that's finance, it's oils planning, it's operations, it's process control, process engineering, instrumentation maintenance, environmental. We'll use it for benchmarking, government reporting, and our value chain optimization group is very interested in the production numbers every day. So, in summary, we're going to transform the existing production accounting data reconciliation systems and work processes. Chevron, the Sigmafine system will now become part of a core business process within Chevron and not some kind of discretionary thing we're doing on the side. We are expecting a significant reduction in the time due to the elimination of redundant work processes that we're doing in PE and process process engineering and planning and finance kind of all doing different things, and we have multiple versions of the truth. We really have this goal of we just want one version of the truth. We want one version of what the heck happened yesterday. So that's the goal of the whole project.